In the last video, we talked about the first stage of training neural networks, the foundation of large language models, which is called pre-training. This stage involves creating a high-quality, diverse version of the internet by filtering out low-quality data. The end result is something like a giant one-dimensional string of text, stretching from beginning to end. Think of it like a huge file. These are the first few pages from FineWeb. Once the raw data is pre-processed, the second and the next big step is called tokenization. Neural networks, the core of LLMs, work with one-dimensional sequences of discrete symbols. These symbols come from a limited set of possibilities, often referred to as vocabulary. Now, at the lowest level, text is stored on computers as bits, just zeros and ones, using encodings like UTF-8. This is the binary representation of the raw text data we saw earlier, of this data. But feeding such long binary sequences into a neural network is incredibly inefficient. So instead, we need more meaningful symbols to keep the sequence lengths manageable. A basic improvement is to group bits into bytes, which are 8 bits each. This gives us 256 possible values. So the text can be represented as a sequence of bytes, each with a unique ID from 0 to 255. But modern LLMs take this a step further using a technique called Byte Pair Encoding, or BPE, or something very similar. Here's how BPE works at a higher level. It starts with all the bytes in the data. Then it finds the most frequent pair of consecutive symbols. Say the byte for O followed by a space. O followed by a space, and merges them into a new symbol with a new ID. These are all accuracies of O followed by a space. Every time that pair appears in the data, it gets replaced by the new symbol. This process repeats, reducing the length of the sequence while increasing the vocabulary size with each new merge. It continues until the vocabulary reaches a target size, usually around 100,000 symbols. For example, GPT-4 uses a vocabulary of 100,277 symbols. This whole process of turning raw text into these compact numerical representations is called tokenization, and the output symbols are called tokens. These are the tokens for this raw text data. Pre-training datasets are huge, resulting in incredibly long sequences of tokens. The FineWeb dataset, for example, contains around 15 trillion tokens. These tokens are what the model learns from to understand and generate language. If you want to see how tokenization works in practice, check out this tool, Tick Tokenizer. Just pick a model and start typing. For example, learning how LLMs work is broken into 7 tokens. You'll notice how tokens don't always match up one-to-one with words. they are optimized for efficiency. Coming back to the FineWeb dataset, this is the token representation of the first few pages of the data. Just think of these numbers as unique IDs. To wrap up, tokenization is a key step that transforms pre-processed internet text into a format neural networks can learn from. This format is usually a one-dimensional sequence of finite symbols called tokens. Tokenization makes it possible for LLMs to discover patterns, relationships, and meaning across vast amounts of data. We've covered the first two steps of training the deep neural network used by the LLM: getting and filtering the raw internet data and transforming it into tokens. In the next video, we'll discuss the next step, which is training the neural network.